Hello everyone. Already we have completed the voltage equation of alternator, including the pitch factor and form factor and the distribution factor. So ultimately what we got the generated EMF. We got the generated EMF per phase is 4.44 kc kT F phi T, whereas kc is your what as coil factor, pitch factor and the form factor. Here we are considering the distribution factor, form factor and the pitch factor. So that is 4.44 kc kd f phi t. Now we have to consider what ultimately the terminal voltage of an alternator. Till now we got the generated EMF in the alternator. Clear? This 4.44 F phi t, or considering the factors 4.44 Kc, Kd, F phi t are the generated EMF in the alternator. But at the load terminal, it will depend on the load. The actual voltage at the load terminal will also depend on the load. So for that factor, there are some factors which will affect the terminal voltage of an alternator. Try to understand. Till now, whatever we have understand, that was the generated EMF in the alternator. This value, this EG. Try to follow my cursor. But till now, whatever we have understand, it is the generated value, that is EG at the terminal. But we need to find the load voltage, this V. We need to find the V, means the terminal voltage of an alternator. So for that, we have to consider some factors. First of all, what are the factors? First of all is we have to consider the RA, XA and XAR. Means here are the notations. First of all, try to understand. RA is the armature winding resistance per phase. XA is the armature winding leakage reactance. Armature winding leakage reactance per phase. XAR equals to armature reactance per phase. Means there is a, already we have studied the armature reaction in DC generator part. In machine 1 you have studied, that is armature reaction. Here also this armature reactance will be considered. Next one is IA. IA equals to armature current. EG equals to generated EMF per phase and voltage V equals to terminal voltage per phase. So look at the diagram, what we are considering. We are considering EG is the generated voltage here. At the left terminal, we are considering EG as the generated EMF. Now we are having the losses in the RA. This RA means this is pure resistance. So the loss, the current is IA will be in phase with this RA. Here, as the current IA passing through this RA, that will be this IA RA will be in phase, will be in the same phase with IA. There is the voltage drop across RA. But the voltage drop across XA and XAR will be 90-degree difference. That's why we are considering the J factor. Already we know we need to consider, try to follow my cursor, we need to consider J when there is a lead 90 degree or lag minus J when there is a lag, that is minus 90 degree. Here, that's why we are considering the J factor, JIARXA and JIAXAR. Whereas this XA, this RA, first of all, the RA is the resistance of your armature. But there are also some fluxes already in the machine 1. You might have studied the leakage reactance and the armature reaction. So what was the leakage reaction? First of all, just have a small recap. Leakage means there are some fluxes which will not interact with the other, means the stator flux, the armature fluxes will not go to the armature. Means the generated EMF, the fluxes which will not interact both winding are known as leakage fluxes. Those fluxes which will not interact with both of the winding, that is known as a leakage fluxes, and those leakage flux will also create some reactance which is known as leakage reactance, this XA. And also we have studied the armature reaction. I hope you remember cross magnetizing effect and demagnetizing effect. Those are, I guess, you are trying to just try to remember. Already you have studied, that is the armature reaction. Here we have to consider the armature reaction. Okay. Now, this is the equivalent circuit of the alternator, considering the RA, XA and XAR. Okay. So what will be the ultimate voltage in the, if we try to apply the KVL? If we try to apply the KVL, the equation will become, so this is the generated EMF EG will be equal to, see here, this EG will be equal to, first of all, the load V plus IARA plus JIAXA plus JIAXAR. Here, this EG will be supplying this voltages, this 4 voltages, load voltages, and the voltages across the reactances and the resistance. Clear? This resistance will have a drop IARA, this reactance will have a drop JIAXA, and this armature reactance will, armature reaction reactance will be JIAXA. Okay, AR for armature reaction. Here, this one, the reactance of the armature, but leakage reactance of the armature, but this one is the AR, means armature reaction reactance. Clear? So, ultimately the load voltage will be equal to EG minus of the voltage drops. Clear? So, this one will be the, it one will be IG, EG minus IARA minus JIAXA minus JIAXAR. Okay. Now, we have to consider the different cases when we are fixing some values, and we will check what will be happening. First of all, the resistance drop. It is not possible to change the armature resistance. Is it possible? When you are preparing the alternator, the resistance will be fixed. But just for example, if we are changing the armature winding resistance, what will happen? But the other things will be constant. See, for fixed EG, means the generated voltage is constant, the load current is constant, armature current is constant, armature reactance is constant, and the armature reaction reactance will be constant. Then if RA will increase, so the IARA drop will also increase. Means if we are increasing the resistance voltage drop will also increase. So the voltage at the load terminal will decrease, and vice versa. That is written here. That is, increase in armature winding resistance decreases the terminal voltage of the alternator, or vice versa. Clear? Now, similarly, what will happen again? The reactive drop will also increase. Now, if the reactive drop will also increase, means the other things are constant. Same thing will happen. Same increase in the armature winding. Leakage reactance decreases the terminal voltage. The thing is, whatever it is increases, because see, in this equation, you can summarize this one. If the RA, XA or XAR, what is this? If the armature winding resistance RA, if the armature winding leakage reactance XA, and the armature reaction reactance XAR, all three increases, means there is a reduction in terminal voltage. If any one of the three decrease, means there is an increase in terminal voltage, because everything has a minus sign and everything has a considered as a voltage drop. So again, this is same case, reactive drop. but you have to consider some other cases for the case of armature reaction. Just have a small recap.